Hey guys, so we are going to add on to what we started talking about on our bell work when dealing with rational exponents. Remember, rational is fractional. So if you've got a fraction in the exponent, it's a little bit difficult to simplify things, so we tend to turn those into radicals. So first, let's go over a little bit of vocab. So this is like just a simple cube root problem, and we have a few different pieces that are going on. So this, when I know it's a square root or a cube root or a fourth root, and that is because that is what is called the index. Okay, so that tells us when we're simplifying, it's going to tell us how many groups we're looking for or pairs. So in this case, we'd be looking for groups of 3 to try and simplify if you didn't already know what the cube root of 125 was. So this is a radical. Now you know where I get my YouTube name, Radical Rompery. So the square root sign is actually called a radical. And whatever we're taking the root of, that is our radicand. Okay, so that's just some, you're going to hear some of these words pop up. So index, radical, and radicand. All right, so how can we simplify expressions? Let's figure this out. So the first ones, we're just going to write expressions in the opposite form we're given. So if we're given a rational exponent, we're going to write it with a radical, so with that root sign. Or if we're given a radical, then we're going to write it with rational exponent. So we started to talk about this on our bell work yesterday. So we have 2y to the 1/2. So the whole quantity is to the 1/2. So this has a rational exponent. So to rewrite it with a radical, I always want you to start with the index. And the index is always our denominator. So this is going to be the square root of, and our radicand, 2y. Now we have an exponent of 1, so if you wanted, you can put it in parentheses to the first power, but it's not necessary. Okay, so the next one, let's try the cube root of 20z. All we're doing is just kind of going back and forth. So in this case, we have a radical, so we want to turn it into a rational exponent. Yes, you could literally see a question this simple. So what we're going to do is we're going to take this 20z. So I'm going to keep my radicand, and I'm going to put it in parentheses since it's not just like a number or a variable by itself. So I want to make sure that I show that it's grouped. And now I want to figure out what is my fraction. So I always start with that denominator. So in this case, our index is 3, so that goes on the denominator. And I don't have an exponent, so I'm just going to use 1. Cool. That's all you got to do. We're just rewriting. So go ahead, pause the video, and I want you to try the next one. 34 to the 1/4. You try rewriting this as a radical. All right, so hopefully you circled that denominator, so that tells you this time we have a fourth root of 34. And again, the exponent's 1, so we don't have to put it in parentheses and put an exponent outside. That quick. That's all you need. Okay, so that was just some simple rewriting. So now we're going to actually talk about how we can use these skills to simplify. So when we're given a radical like this, so the fourth root of 256. 256 is a pretty large number. And remember, we talked about doing these without a calculator. So if I want to simplify this, my index is super important. It tells me what I'm looking for groups of. So in this case, we need groups of 4 to try and simplify or basically get rid of this radical. That's what we're trying to see if we can do. So I'm going to make a factor tree. Remember, this is basically, I like how Mackenzie said the other day, it's like a division chain. So 256, well, it's even, and I know it's definitely divisible by 2, so I'm going to go ahead and start with 2. So if I divide by 2, that's going to be 128. Okay, so even again, so I'm going to have 2 and 64. Ooh, I like 64. That's a perfect square. So I know that goes into 8 and 8. I'm all excited right now because I got a lot of pairs, but the problem is that index tells us we're looking for groups of 4, so we got to keep going. So I'm going to break down my 8, 4, and 2. What just happened? and 4 and 2. And hey, we've got 1, 2, 3, 4 2s. So then you would think we could stop, but those 4s can still be broken down some more, so we need to do that because I might have another group of 4. So I get a 2, a 2, a 2, a 2, and in fact, we do have another set of 4. So since we had 2 sets, we're going to multiply. Basically, think about it. We divided to break them up, so we multiply to put them back together. So 2 times 2 tells me that the 4th root of 256 is equal to 4. I know, that was kind of a lot of work to figure that out. But yes, this is something that you've got to do without a calculator. Okay, so the next one is 1/27 to the 1/3. All right, so this time we're given a rational exponent. No big deal, but we want to change it to a radical so that we can do this factor tree to break down. So the index tells me my root, it is a cube root of 27. Now I know what the cube root of 27 is, so if you knew that, like you could automatically stop. But in case you don't, I'm going to go ahead and go through that factor tree process again. I know 27 is divisible by 3, 3 times 9, and then 9 is 3 times 3, which is perfect because our index is 3, so we need 3 of something. So therefore we know that 27 to the 1/3 is 3. Is that pretty cool? So this is just using some basic math skills, but you have to know how to rewrite it to be able to actually apply those. All right, so let's get into numbers that look a little yuckier. Don't worry, they're not that bad. So we got 16 to the 7/4. 16 to the 7/4. So again, I have a rational exponent, so I need to rewrite this as a radical. So I take that index, so it is the 4th root of 16. That's a big root. Okay, now this time we have an exponent. So once we find what the 4th root of 16 is, we need to put it to the 7th power. Okay, so 4th root of 16, so I'm going to break that down. So 16, 4 times 4. If you did 2 times 8, that's fine. We're all going to still end up with the same answer. So then 4, 2 times 2, 2 times 2, which is perfect because we're looking for groups of 4. So the 4th root of 16 is 2. Awesome. But now we need to put that to the 7th power. Okay, well, lucky for me, I know that 2 to the 5th is 32, so that saves me a little bit of work. So I'm going to start there. So 2 to the 5th is 32, times 2 is 64, times 1 more 2 is 128. So 128. So 16 to the 7/4 is equivalent to 128. All right. One more that I wanted to show you. I'm running out of room, so I'm going to put it off to the side. I wanted you to see how we can do the same thing, but with a fraction. So we've got 216 over 64. I don't even know. 64ths? 216 64ths? All right. To the 2/3. 216 64ths to the 2/3. All right, so again, we're going to rewrite as a radical. So I need a cube root. This whole thing, 216 over 64. And we got an exponent again. So once we find that answer, we'll square it. Okay, I'm going to do these separate just because that's a lot to look at. So first I'm going to tackle the cube root of 216. Wait, did we already do 216? Or am I just... No, we had a 128. Okay, so 216. So I'm going to start breaking that down. 2, so that would be 108. And 2 again, 54. Beautiful. All right, what are we looking for groups of? Okay, so groups of 3. So I'm going to divide this by 2 again. That way I'll have 3 2s, and that'll give me 27. Okay, so we've got one group of 3. but we got to keep going to 27. Now, hopefully you remembered the cube root of 27 is 3. Then you could have stopped. But if not, we'll keep breaking down 3 and 9, 3 and 3. So 2 times 3 gives me 6. Okay, so that's the cube root of 216. Now we got to find the cube root of 64. Again, I know it's a little bit of work. It's not that it's that difficult, though. All right, so 64. I'm going to start with 4 and 16. And then 16 gives me 4 and 4. You could have started with 2 as well. I just remembered that I already actually knew that 4 times 4 times 4 is 64. So that's how I kind of started with that hint. So the cube root of 64 equals 4. So now we can rewrite because we just found the cube root of 216 was 6. And then the cube root of 64 was 4. So now I need to square. Don't forget about squaring, okay? We need to square our 6/4. So I'm going to simplify this actually. So 6/4 would be 3/2. So now I'm just squaring a 3 and a 2. So 3 squared is 9, 2 squared is 4. So this hot mess over here is equal to 9/4. That's pretty crazy. All that work for a simple little 9/4. So if you are given a fraction, just make sure you split them up to make it a little easier. If you try and do it all at once, if you don't already know what that cube is, then you're going to be in trouble. If you had Mrs. Krieger last year, you might want to brush up on that cube root song because that'll definitely help you. Okay, we got to apply it. So we're given a function here. It says the frequency of a note measured in hertz or vibrations per second played on a perfectly tuned violin is given by f sub n equals 440 times 2 to the n over 12, where n is the number of notes above the note A4. What is the frequency of A6? And there's our important info, which is 24 notes above A4. So again, what does n represent? Well, the number of notes above A4, which they told us is 24. So literally all we're doing here is plugging in. So 440 times 2 to the 24 divided by 12. Oh, this is nice. So 440 times 2 squared. So 440 times 4 is 1760. So the frequency, what is it, hertz? So 1,760 hertz. I'm sorry, I'm not a math person. I am a math person. I'm not a music person, so I'm not exactly sure what that means. But for my band people, you can explain that to me tomorrow. All right, last 2, applying properties of exponents. So we know all these rules about exponents. Let's see if we can put them to use and help us simplify a little bit easier. So 81 to the 3/4 divided by 81 to the 5/4. This is awesome because we have the same base. Both of these are 81. So I can use my MadSim. When dividing, subtract the exponents. So 5/4 is bigger than 3/4. Oh, they were nice. We already have common denominators. So to cancel these, I'm going to subtract 3/4. Okay, we just talked about this the other day. If everything disappears in your numerator, don't forget your one placeholder. All right, so 81 to the 2/4, which simplifies to 1/2. So now I'm thinking, okay, we're just taking the square root of 81. Right? Because 2 is my index. And what's the square root of 81? 9 times 9. 1